What are hashable objects? The elements in a set must be hashable. Strings and numbers are hashable. Tuples of strings and numbers are hashable. Lists are not hashable. The keys in a dictionary also have to be hashable. So strings, numbers, and tuples of strings and numbers are valid dictionary keys, but lists are not valid dictionary keys. Set and dictionary lookups both rely on the hashability of an object to make their containment checks fast. Here we're looping over a list of 20,000 numbers, and we're filtering that list down to just the numbers whose two neighboring numbers are not in the same list. This code takes a while to run, takes about 10 seconds to run. The reason is that in-operator lookup requires looping over the whole list to figure out whether that number is in the list. If instead we create a new set out of that list and then run the same code again, but look up the neighboring numbers in the set, Python runs this code basically instantly. When we use the in operator on a set, Python uses some math magic to answer our question very quickly without even looping over the set. This math magic relies on the fact that every hashable object has a hash value. You can see this hash value by passing an object to the built-in hash function, though you don't really need to because we don't need to care about these numbers. So this weird number here represents the hash value of the string tray in my Python interpreter. The hash value of an object is meant to semi-uniquely represent that object. Sets and dictionaries use this number to figure out where to store different objects so they can quickly find them by their hash value. You can think of it as like an indexing system or a cataloging system. Immutable objects tend to be hashable. So strings, numbers, and tuples are all hashable. Mutable objects are usually not hashable, so lists are not hashable. The hash value of an object should correspond to that object's sense of equality. So we have two tuples here that represent the same data. They're equal, but they're also hashable, which means the hash value of one of these tuples should be the same as the hash value of the other tuple, which means that if we put these two tuples in a set, we'll only get one of them in that set, because from the perspective of hashability and equality in Python, these are basically the same tuple. So the hash value of an object should correspond to that object's sense of equality, but also the hash value of an object should never change over the lifetime of that object. This is the reason that most mutable objects aren't hashable, because often a mutable object's sense of equality can change over the lifetime of that object, which would mean its hash value could change, which would be a problem if it was hashable. Hashable objects can be elements in a set or can be keys in a dictionary. If the answer to the question, is object A equal to object B, can change over the lifetime of those two objects, then probably at least one of those objects is not hashable. Hashable objects in Python tend to be immutable, though not always.